All right, so solving radical equations. Radical equations means an equation that's got a square root in it. That's what a radical equation is. The key to this is, remember when we were solving by taking square roots, we tried to get the square part by itself? Well, this is kind of the opposite of that. We want to try to get the radical by itself. Okay. All right. So the radical, meaning the square root part by itself. So we'll start with a pretty easy example. The square root of x is equal to 4. On this one, the square root is by itself. The opposite of taking a square root is what? Which is the same thing. What do you call that when you multiply something times itself? Squaring. The opposite of taking a square root is squaring. Or the opposite of squaring something was take the square root. Here we're trying to get rid of the square root, so we would square both sides. Okay? And then on the left side, the side that the radical is on, it just goes away and it's just x. And then on the right side, what's 4 times 4? And you've solved it. That's the answer.
It's just going backwards.
Yes, it's just going backwards. That's exactly right.
Oh, okay.
All right. So example B is the radical by itself. No, it's got the 3 on the front. That's 3 times the square root of x. So how do we get rid of the 3? Divide by 3 first. $15 divided by 3 is 5. Now the radical, the square root is by itself. The opposite of taking the square root is squaring both sides. So far, so easy. The left side, the square root goes away. So got x, and on this side, 5 squared is.
Okay, so what did you say you did right there?
Squared both sides.
Okay, you squared both sides. So
Yeah, that's what that says. It's squared both sides.
2.
5 times 5. That's squaring.
You can laugh at me, guys. I'm just trying to learn.
Now, guys, stop talking, please. All right. Example C, square root of x plus 3 is equal to 10. All right, so we're trying to get the square root by itself. The plus 3 is in the way, so we're going to move it by subtracting 3. So we get square root of x is equal to 10 minus 3 would be 7. And then to get rid of the square root, you square. 49. Hey, good morning. Set one of those seats there. You did a quiz, right? All right, so let's look at example D. 2 square root of x minus 8 is equal to 0. So we're going to get the square root by itself. So plus 8 is the right move first. So that's 2 square root of x equal to 8. Then what? Divide by 2. That gets the square root by itself. What do we? Yeah, it is. It's just adding a little bit more of what we've learned back to the problem. So now, what do we do next?
The square thing with the 2.
Square everything.
It'd be 8.
No. Be 16. 4 times 4.
I almost got it.
Say it again, Jalen. A lot of it, yeah. Well, we don't have the plus and minus here because we're not taking the square root of the thing. So we may encounter some quadratics here in just a little bit that we might have to solve to get the answers. Let's take this one. 12 square root of x minus 2 equals 1. What's the first step? Let's add 2. That's 3. You got 12 radical x. Divide by 12. Square root of x. 3 over 12 turns into 1/4. And then we do what? Square both sides.
So now that's 1.
It's not. 1/4 times 1/4. 1 times 1 is 1. 4 times 4 is 16. So it's 1 over 16. All you got to do is square the top and square the bottom. And it makes it's always been that easy. All right, so this one's a little different. The minus 5's on the inside of the square root instead on the outside. So is the radical part by itself?
No.
Yeah, it just happens to be a little bit more complicated stuff inside of the radical. But it's by itself, so we need to get rid of it. By doing what? Squaring both sides. And that just gives us x minus 5 is equal to 36. And that's a chapter 3 equation now, right? So just add 5. Yeah, 8th grade problem, 7th grade problem, 6th graders do this. They don't do the squaring part, but they do the x is equal to 41. Okay? You've got to make sure we're getting the radical by itself. Once you have the radical by itself, squaring is what you do next. So whatever happens, you're getting the radical by itself and then square both sides. 4 square root of x minus 7 plus 12 equals 28. And you'll see me put a little tail right here, and I do that so that you see the square root ends right there. Whatever's after that is not under the square root. And sometimes I get a little carried away with drawing my square root. So what's the first step on this one? Right, 12. $28 minus 12 is 16. Now what? Divide by the 4 on both sides. So that's the square root of x minus 7 is equal to 4. Is the radical by itself? Yes. So the square root is by itself, so I can take that and square both sides to get rid of the square root. So that's x minus 7 equals 16. And add 7. What's 16 plus 7? 23. And you've got the solution. A little bit.
I think I could handle that.
Let's see if we can do this one. 2 square root of x plus 6 plus 9 is equal to 21. Subtract 9 first. And then so that's 2 square root of x plus 6 equals how much? 12. Now what? Divide by 2. Square root of x plus 6, excuse me, is equal to 6. Now what? Square both sides. What's 6 squared? 36. We've seen that one already today. Now, subtract 6. X equals 30. This is a little different. Okay, what would that do? Yeah, it gets rid of the square roots on both sides. Since you got a square root on each side, they're technically by themselves. So if you square both sides, that gets rid of the square root on both sides. That's mathematically legal because you're doing the same thing to each side of the problem. And as Emily said, that's 2x minus 7 and x plus 2. Okay, you could add 7. So that's 2x is equal to x plus 9. Subtract x. So that would be x is equal to 9. You got our answer. So looked like a really tough problem at the beginning because it had 2 square roots, but it's not. It's actually easier than the others because there's a little bit less math work to do, arithmetic wise. Tim, turn around in your desk and face forward. Jordan, sit up. Take the earbuds out of your ears. Mr. Walker, take the earbuds out of your ears and sit up. All right. Now this one's a little bit different, but it's similar to the previous problem because it's got 2 square roots in it. This one can be done kind of with a little bit of trickery in that it's got 0 on this side. So if I moved this to that side, I'm adding it to 0, right? And adding something to 0 doesn't change what we're adding, right? So it'd be 0 plus the square root of x. And that would just be square root of x. So that's the kind of maybe the trick to doing this one, the easy way. 4x minus 3 equals the square root of x. And now it looks a lot like the previous problem because you got a square root on each side. And what do we do next? Square both sides. F or 4x minus 3 is equal to x. And now this should get x by itself. So subtract 4x. It's going to give us negative 3 is equal to negative 3x. Divide by negative 3. X is 1. So that's going to be a useful thing for some problems that you're going to encounter. Won't necessarily work for every problem, but it works for some of them. Makes it a lot easier. Let's get into a little bit more difficult problem. Example K. Square root 6 minus x equals x. So it's similar in that you got a square root on one side and then you got an x on the other side, but there's not a square root on the right-hand side. So this is a little different, but similar idea, Molly. No. You can't square individual pieces on the same side. If you square one side of the problem, you have to square, like multiply. You would have to multiply out square root of 4x minus 3 minus the square root of x times itself again. That's what squaring. It's not mathematically legal to just square individual pieces. Squaring the whole left side means you square like that, and that's not the way you want to do that problem. You would have stumbled into the correct answer, but it won't work every time. If there was something besides a plain x in there, it definitely wouldn't work. All right, so let's look at this one. Is the radical by itself? Yeah, so we need to get rid of it. So what do? Square both sides. So when I square the left side, just gets rid of the square root, 6 minus x. But what's x times itself? It's x squared. All right, so that's got an x squared in the problem. So to solve it, we need to get it equal to what? 0, which is what we've been doing for the last month or so. So we're going to add x and subtract 6. That'll get us a 0 over here, x squared plus x minus 6. And I moved those two pieces, even though it was 2 steps to move them. I moved them there because I want to keep the x squared positive. If I don't keep it positive, it makes my factoring or whatever I have them set up. So when we get it equal to 0, we got options as far as how to solve it. We can do factoring, x method, because it's a trinomial. We could do quadratic formula, which is what we just did last week. Either of those methods would work for this one. Remember that not every quadratic will factor, but every one of them will work with the quadratic formula. We can work it with the quadratic formula. So you pick your method. I'm gonna factor this one and get the answers. So 1 times -6 is -6. We need that to add to be +1. So that'd be 3 and -2. My factors would be x plus 3, x minus 2. So that means x plus 3 equals 0, x minus 2 equals 0. And I solve each one of those. So x equals +2 and x equals -3. Now, this one's a little different because I got 2 answers to a problem that originally did not have x squared in it. So I need to check to make sure both of those work. Technically, you should check every problem and plug your answers back in and make sure they work. But for this one, we need to check them for sure. So if I plug in, I'm going to do the 2 first. In the original problem, if I'll go back up there and go 6 minus 2, that'd be the square root of 4. Is the square root of 4 2? That works. Now, if I did 6 minus -3, that'd be the square root of 9. Is the square root of 9 -3? No, it's not. There's no plus or minus in the original problem. So it has to be the principal square root, which is the original problem had just the square root of 6 minus x. There's no minus sign in front of it, so it's only the positive side of it that we're looking at. So here, this is not true. So we throw out that answer. That is what's called, the term for that is extraneous solution. So we found it. It was in there, but it doesn't work in the original problem. It's called an extraneous solution. Look at the first 5 letters of that's extraneous. 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 So it's an extra answer, but it doesn't work in the original, so you throw it out. A lot of times you will throw out the negative answer, but you won't always throw out the negative answer when you get 2 of them. You've got to check them in the original to see which one to throw out. Okay, so it's possible that you keep the negative one. Not always, but very often you throw out the negative. Let's try this one. X is equal to the square root of 20 minus x. Similar problem. Is the radical by itself? Yes. So if the radical is by itself, take the square, not take the square root, but square both sides. And again, we've got an x squared in the problem. So if we've got an x squared in the problem, that means we need to get it equal to what? Equal to 0. So I'm going to add x and subtract 20. It's going to give me the 0 there, and I get x squared plus x minus 20. And you could solve that either by factoring or quadratic formula. I'm going to do this one both ways. I'll do it with factoring and quadratic formula. So we'll do quadratic formula first. X equals negative b plus or minus the square root. Hey, thank you. B squared, so 1 squared minus 4. You going to stick around and learn a little quadratic?
Squares. B's are not squares. They got arcs.
That's true.
Now, if you took 2 L's and inverted one of them,
You'd have a rectangle, not a square. History, guys. All right, so 2 times 1. All right. So this is using quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. That's what we did last week. All right. We work this out. So that'd be 81 under there. What's the square root of 81? 9. So then we split that up. Negative 1 plus 9 over 2. So that'd be 8 over 2 is 4. And then negative 5. If you did it by factoring, that'd be 5 and negative 4. So your factors would be x minus 4, x plus 5. So there's the x equals 4, x plus 5 equals 0. There's the x equals negative 5. I get the same 2 answers no matter which way I solve that, by factoring or by quadratic formula. Got to be able to do one of those at least. Okay. Now we got 2 answers. We need to check them to make sure they work. So if we go back to the original problem, if I plug in 4, 4 is equal to 20 minus 4 under a square root. 20 minus 4 would be 16. Is the square root of 16 4? Yes. And it's the positive side because it doesn't have a minus in front of the radical. Okay, if we plug in negative 5, we get negative 5 is equal to 20 minus negative 5, which would be 25. But it's the positive square root, and we have a negative over here. So that it doesn't work. So that's our extraneous solution. So we throw that out. So x equals 4 is our only solution to this one. That's the only solution we have. They don't get much more complicated than those. That's as hard as they really get, guys. And most of the ones you're going to see will solve by factoring or quadratic formula either way in this section. It's not They don't get any more complicated than the last two examples that we've done. Okay. When you come back from lunch, you need to be working on this assignment, page 732. We're going to do 3 through 27. Let's do all of them today. You got an hour to work when you come back. Tomorrow we'll do a little bit more practice with this, go over some questions that you might have for it, and then Thursday we'll quiz over this stuff. Then Friday you're out for Good Friday. So being out yesterday kind of throws us in a little bit of a tough spot. But either way, we're going to finish up this and go from there. Okay. So hang on just a second. Let me explain to you what happened.